Here's a quick overview. We will start by first understanding what defines a smart city and why it is becoming increasingly important. Second, how intelligent infrastructure has evolved over time. Third, explore the role of AI and digital technologies. Fourth, study different aspects, how integration in urban systems. After that, fifth, the role of governance and partnerships, implementation, global industry insights with the future outlook and investment opportunities for smart cities.
Smart City Vision. This is a vision statement guiding the entire strategy. Smart cities aren't just about adding sensors and dashboards in the city. The goal is quality of life. A smart city is defined by three qualities: intelligent, sustainable, and connected. It leverages digital technologies to improve quality of life, enhance public services, and optimize how urban sources like water, energy, and transportation are managed. The outcome is resilient, citizen centric communities, places built around the people living in them, not just the infrastructure being underneath them. Critically, this drives economic growth while promoting environmental sustainability at the same time, rather than treating those as competing priorities. That combination, growth and sustainability moving together, is what separates a genuinely smart city from a simply automated one.
As the graph shows, the smart cities market is projected to grow significantly from $2.25 trillion in 2025 to $15.92 trillion in 2035, reflecting rapid global urbanization and technological advancement. This represents a strong and consistent upward trend, highlighting the expanding opportunities in smart cities infrastructure, AI, IoT, and connected urban systems.
Intelligent infrastructure evolution. This timeline shows how smart cities have evolved over last 2 decades. The journey started in first 1999, where Arun Mahijan introduced smart city concept. It was just a vision by then. Second, around 2005, sustainable city designs such as Tincton Eco City emerged. Third, in 2009, Santander demonstrated how sensors could transform intelligent infrastructure evolution. This timeline shows how smart cities have evolved over last 2 decades. The journey started in first 1999 when Arun Mahijan introduced the smart city concept. It was just a vision. Second, around 2005, sustainable city designs such as Tincton Eco City emerged. Third, in 2009, Smart Santander demonstrated how sensors could transform into an existing city into a living laboratory. Thousands of sensors were installed to collect different types of data. Then projects like Master City and Songondo then showed how infrastructure could be digitally connected from the beginning. More recently, cities such as Dubai have adopted predictive AI to anticipate traffic, energy demand, and public services instead of simply reacting to problems. Looking ahead, concepts like Tilosa and Forest City envision cities that combine advanced technology with sustainability and improved quality of life. Overall, the evolution has moved from isolated technologies toward fully integrated, intelligent, and citizen centric urban ecosystems.
AI and digital technologies. Here's how AI and digital technologies come together to power urban planning. It starts with the Internet of Things, smart sensors and devices performing real time data collection and environmental monitoring across the city. The data spreads two ways. Some gets processed locally through edge computing, reducing latency and delivering faster responses at the source, while the rest moves through 5G and emerging connectivity, built for high-speed transmission and massive device connectivity. Both paths feed cloud infrastructure, providing scalable storage and big data analytics. All of it converges into a digital twin of the city, a real-time virtual replica used for simulation, modeling, and live dashboards, which then drives AI-powered urban planning. land use optimization, design, simulation, and data-driven decisions.
So let's get a deeper look on integrated urban systems. So the AI-driven coordination of transportation, energy, and buildings enables real-time efficiency and a better quality of life for its citizens by connecting the city's critical infrastructure like transportation. Transportation includes AI traffic management, connected mobility, and adaptive routing. Energy, smart grids, renewable integration, demand response control. Buildings, intelligent HVAC, occupancy analytics, and performance monitoring. All together are unified through real time data coordination across city systems. The key outcomes of integrated urban systems are real time coordination across city systems, lower operating costs through automation, better service delivery, and citizen experience.
Integration of core urban infrastructure systems. This chart highlights how extensively different urban systems are being benefited from smart city infrastructures. Transportation leads the way at 96%, driven by AI based traffic management, connected mobility, and smart parking solutions. After that, energy grids follow closely with smart meters and renewable energy integration. Services like public safety, water management, and healthcare hold a little less weightage as compared to former two. Waste management and government are also becoming increasingly digital. The overall message is that smart cities are not focused on a single technology. Instead, they connect multiple sectors, enabling better quality of life for citizens.
Governance and partnerships. These are what make this entire system trustworthy and sustainable. Smart cities require collaborative governance, robust regulation, and strategic partnerships between government, industry, and investor. Three pillar anchors that governance. First, data governance and privacy, setting clear rules for ownership, consent, and citizen privacy. Second, AI ethics, ensuring accountability, bias checks, and explainability in every deployed system. And third, cybersecurity, securing infrastructure and establishing response protocols and interoperability standards. Supporting all of this is a three-way stakeholder ecosystem. Government setting policy and regulation, technology providers delivering platforms and integration, and investors supplying capital through public-private partnerships, bonds, and infrastructure funds. None of the technology matters with governance and partnerships. These are what make this entire system trustworthy and sustainable. Smart cities require collaborative governance, robust regulation, and strategic partnerships between government, industry, and investors. Three pillar anchors that governance: data governance and privacy, setting clear rules for ownership, consent, and citizen privacy. Second, AI ethics, ensuring accountability, bias checks, and explainability in every deployed system. And third, cybersecurity, securing infrastructure and establishing response protocols and interoperability standards. Supporting all of this is a three-way stakeholder ecosystem. Government setting policy and regulation, technology providers delivering platforms and integration, and investors supplying capital through public-private partnerships, bonds, and infrastructure funds. None of this technology matters without this foundation underneath it.
So let's analyze this data chart on public-private collaboration across different smart city projects. So this chart shows that the private sector participation is strongest in digital infrastructure, that is 58%, in transportation, that is 54%, and smart buildings, that is 55%, while the public sector leads in public safety, water management. Overall, the data highlights the importance of public private relationships in delivering smart city infrastructure and services across diverse sectors.
Implementation and readiness. When we move for implementation part, several questions arise like, is digital infrastructure available? Is internet coverage good? Can city collect reliable data? Successfully building a smart city requires more than just deploying new technologies. The first step is to assess city's readiness by evaluating its digital infrastructure, data capabilities, and overall maturity. Next, governments need to establish clear policies for data governance, cybersecurity, AI ethics, and procurement. Once the foundation is in place, investment must be secured through government funding, private partnerships, or public private partnership models. Finally, projects are implemented and the impact is continuously measured using key performance indicators such as traffic reduction and others. This structured roadmap helps cities scale smart infrastructure effectively and sustainably.
Industry and global insights. This covers how different industries are applying these technologies and what the leading cities prove is already possible. In energy and utilities, smart grids and battery storage are modernizing delivery and accelerating renewable integration. In transportation and telecom, 5G and IoT enable intelligent transportation, mobility as a service, and autonomous traffic management. In real estate and construction, green building design paired with AI-driven HVAC and occupancy analytics is driving major energy efficiency gains. This approach builds directly on proven strategies from global pioneer cities like Singapore, Tokyo, Barcelona, and Dubai, demonstrating scalable governance models, public private investment structures, and large scale digital deployment.
So let's dive deeper in the future outlook and investments for smart cities. Here we are studying four different aspects: the growth megatrends, that is, prioritizing long term technology roadmaps, emerging megatrends through different development scenarios through 2035. Next, we study capital allocation, that is, prescriptive insights driving proactive business actions, enabling organization to anticipate outcomes and optimize the decisions in real time. The financing mechanisms include mobilized diversified funding streams using green bonds, specialized infrastructure funds, and municipal financing instruments. Finally, the partnership models, scaling deployment through public private partnerships and clear risk allocation framework for sustainable cities.
To conclude, smart cities represent the future of urban development. AI and digital technologies are enabling cities to become more intelligent, efficient, and sustainable. Real time data helps improve public services, optimize resources, and enhance safety. At the same time, strong collaboration between government, technology providers, and investors is essential for successful implementation. Ultimately, the goal is to build resilient, connected cities that are prepared to meet the challenges of the future.